Okay, let's dive right into today's explainer and unpack the anatomy of a comprehensive hardware and prototyping supplier. We've got this fascinating piece of source material from a company called BrickOnix. Now, at first glance, yeah, it kind of just looks like your standard product sheet, but stick with me, because as we break this down, you're going to see how it actually reveals an entire ecosystem designed for creators, engineers, and industrial innovators. We're going to explore exactly how a supplier like this positions itself as that absolutely crucial bridge between a raw, fuzzy idea and a polished, finished, physical product. Build, innovate, automate. The source material kicks things off with these three powerful words, and honestly, it sets such a high-energy tone right out of the gate. They aren't just giving us a boring list of what they sell, they're literally mapping out what you can achieve with them. It's a clear progression, right? You build a prototype, you innovate on that design, and eventually, you automate the whole process. It's basically the entire product lifecycle captured in just 3 words.
So let's start with Section 1, Building and Innovating, looking at those first 2 pillars. When you look at the overall promotional flyer, it definitely looks like a pretty straightforward advertisement for 3D printer filament. But structurally, if we zoom out a bit, it reveals a much deeper engineering ecosystem. It centers on those raw physical materials, sure, but then it surrounds them with really specific guarantees, precise applications, and this massive foundational base of support services. Moving on to Section 2, let's talk about the filament arsenal, the raw building blocks.
To pull off that build phase, BrickOnix offers a seriously diverse arsenal of standard 1 kilogram spools. And what's cool is they ensure makers have access to the full spectrum of physical properties. We're talking standard PLA and PETG for your rapid drafting, flexible TPU for pliable parts, all the way up to high-strength carbon fiber and ABS for hardcore, durable engineering. By offering these specific 5 varieties, they're pretty much covering the vast majority of requirements an engineer or designer would ever need to test out a functional prototype.
Because, it's not just about melting plastic, right? It's all about the structural integrity of the final built object. The source material specifically emphasizes that these diverse materials are engineered to yield stronger prints and smoother results. It's directly connecting that raw material to the creator's potential to unlock endless possibilities.
Which brings us to Section 3, Guarantees and Applications. Because let's face it, reliability is everything.
They back up these materials with 4 very specific guarantees: premium quality, consistent diameter, smooth and reliable prints, and strong and durable. Now, if you've ever woken up to a giant spaghetti monster of failed plastic on your print bed, you know that a consistent diameter is basically the holy trinity of 3D printing success. By actively highlighting this, BrickOnix is sending a clear signal to experienced makers. They're saying, hey, we understand the technical pain points of prototyping, and we're actively preventing them to give you true reliability. And because of those strict reliability guarantees, these materials can easily bridge the gap between, say, a weekend DIY project and serious professional engineering parts. They're actively courting the hobbyist who's just making a custom bracket at home in their garage, all the way up to the professional engineer iterating on a super complex mechanical assembly. The materials are positioned as robust enough to handle literally the entire spectrum of creation.
All right, Section 4, Complete Prototyping Ecosystem. Let's look at full-scale innovation.
Hidden down in the footer of the source material is a pretty massive reveal. BrickOnix isn't just selling plastic, they actually provide a complete suite of services for the innovate and automate phases of their mission. We're talking electronics and components, automation and robotics, CAD design and design for manufacturing services, CNC machining, and industrial tools. They've built an entire ecosystem. Conceptually, you could walk in with just a napkin sketch, use their CAD services to design it, 3D print a prototype, integrate their electronics to automate it, and finally get it CNC machined for actual production. That is a real game changer.
And this brings us to a really distinct strategic advantage, and that's their location. They are positioned directly inside the National Science and Technology Park, or NSTP, at Noost in Islamabad, Pakistan. So they are physically embedded right at the source of local engineering talent and research. Now, obviously, they're accessible globally via their website and email, but this physical positioning is absolutely key to their operation.
So what does this all mean? Think about how having this entire ecosystem locally available just completely empowers professionals and students to rapidly iterate. I mean, what is the true impact on the speed of technological development when a complete industrial pipeline, from raw filament to advanced automation and CNC prototyping, is consolidated under a single localized roof?
It's a question that really redefines how we think about modern hardware development, and honestly, it leaves us wondering just what incredible things are being built, innovated, and automated there right now.